Hello and welcome to another presentation of India's Education. This is the sixth series of the robotic tutorials. In this tutorial, I will demonstrate the fully working physical robot. So remember the previous tutorial, I demonstrated the fully working virtual robot. Just to give some background, let's focus on the screen. The whole tutorial is based on the project I've done in my master's. So I published the project in various form. I made all the YouTube videos. I published my research paper. Also in my website, I made the detailed tutorial with all the links you require to carry on this project, and you are more than welcome to join on board and practice my project, contribute yourself, make things more advanced for you, and you can count on my help. Let's get to the tutorial first. So this is the physical car, as you can see. Let me attach the webcam on it. But before that, as you can see, this is the tutorial. This is the online tutorial. I made a nice lighting picture for you. So this is the virtual robot which I published last week, and this is the physical robot which I will be discussing today with all the explanation of the Python programming code and the hardware specification and the working mechanism of all the hardwares. So we got our car, so then I started building all the CAD parts just to visualize the virtual robot. Also the simulation is the most important part of this code building. So these are all the codes, different stages of code development. I published the tutorial as well as the code as well, so you can go through week by week and practice yourself. Also things to keep in mind that I will provide a link of the fully functional Raspberry Pi 4 image, where you don't need to download the OpenCV yourself. You just copy the image and burn it to your SD card, put the SD card inside your Raspberry Pi 4, then it is ready to deploy. The OpenCV 4.1 and some other code as well. This will be really handy for the newcomer who just first time getting started with Raspberry Pi 4. You don't have to build all the software dependency yourself. Now this code was for Raspberry Pi 4 motor control. As you can see, it has got 4 TT motors. So this code is for the motor control, and these are the Python code for, I believe these are for when you see error code equal vref.simset join target velocity, this kind of code word, that means that these are for virtual robot. Okay. So last week this was the completion of the virtual robot, and this week, as we are tracking now, this is the completion this is the completion of the physical robot. This robot will be don't think that this is just the end of the project. This is literally the start of the project. So we got our working prototype of the robot, which is somehow working, which has got some volatility with its code, but at least it is responding with the visual feedback. The motors are moving, things are like that, but obviously it's not perfect, it's not fully deployable yet. So now this is our machine. In this machine, multidisciplinary programmer can join to my project. So basically this is the base project, and you can build your own project based on this project. You can make your you can just deploy all of your machine learning code, all the machine learning skill you have learned over the years. You can apply to this project. You can apply data science project. You can apply your MATLAB code. You can apply your Python code, also your C code as well. Now let's get started with the basic configuration. So the basic configuration of the machine is that it has got the buck converter. Just to see if you see, yeah. So if it has got the buck converter, and it has got 12-volt battery inside, as you can see, the 12-volt battery inside. So buck converter gets charged from the battery. Buck converter, it converts 12-volt to 5.0 volt for Raspberry Pi 4 operation. So as I'm plugging the motor controller, then I'm plugging the buck converter. So now I just check, yeah, so the buck converter is getting 5.0 volt, and all the thing I built up in modular approach where you can change parts, change different codes, also change different hardware as well. So for instance, this one you can change yourself at any time. Even the Raspberry Pi 4 itself, you can just take it off at any time. Many of you who has already seen my Raspberry Pi 4 power supply module tutorial, many of you are suspecting that my thing is not charging, the buck converter is not charging the Raspberry Pi 4. I can show you it in real time. As you can see, it is showing the 5.0 volt, and all I have to do is just check it. Yeah, all I have to do is just plugging in my controller inside. So as you can see, okay, before that I need to put the SD card. I forgot to get the SD card from my other Raspberry Pi 4. Now I've got my, let me put my SD card first. So I put my SD card. Yes. Well, let's see what happened now. Strange, the BGA has got, doesn't have any signal, so let's put it back again. So the Raspberry Pi 4 itself is on. I can show you the camera. No, it's not possible to see this time, but I'll let you see this. Now I will attach the webcam. So yeah, so everything is in modular approach. As you can see, it has got very resemblance with the physical webcam. Let's plug it in. Okay. Now the bubble screen is starting. Okay. Yeah, so I'm just opening the Spider 3 IDE where all the codes will be played. Spider 3 is very user friendly, the way I would say, because it has got this MATLAB like interface. Many of you who are more familiar with MATLAB, getting started in Raspberry Pi or in Python, I would say in general, would be really beneficial if you use this code. So what happened if I just play it? So if I play this code, as you can see, it is can only see me right now at the moment, but if I just get my blue patch, yeah, so this let get this blue card. So as I am going along, it is trying to measure randomly, but that's not happening because this card is more customized. This card is more customized for the block. Let me get the block first. Yes, so I've got my block. So basically, it is getting it, trying to figure it out. Yeah. So the camera has identified that blob is left hand side of the camera. So if I get it other side, it has identified the blob is right hand side of the camera. For some reason, okay, so if I go left hand side, the motor react to that. If I go on the right hand side, this time this motor is moving. So it is trying to compensating the target movement with its motor movement. For some reason, the right side motor, this one is not working. It's supposed to be interact with the camera code. So I will see what is happening. So basically, before I am going further, just take it. The summary is that the whole project is based on the computer vision sensor. The vision sensor can identify certain object from a great distance. So the vision sensor can identify object from a great distance, and then it can measure how far it is, and it can measure the location as well. So at the moment I am just holding it at the center, almost center, so it is showing that it is on center location. This part, as you can see, it is showing it is on center location. As I am going right, it is showing the target is right location compared to where the field of vision of the camera is. And if I move just left, the feedback is showing that it has identified that the target had moved left. In reality, this motor was supposed to move, and it's supposed to compensate that how far it's supposed to compensate the location of the center target. Now this how we started, and I will figure out what is happening with the right motor. Okay, that's what is happening here. It's probably one of the things has been taken off. So if we just connect it. Yes, I have to go through the diagram again. Probably one of the pin has been dislodged, which next tutorial I will try to get it right. The setback of this code is that it crashes frequently because the code optimization hasn't been completed yet. Now, because this time the code has crashed and it is not playing the code, that means there is something wrong with the current code configuration. Over the coming tutorials, I will be optimizing this code I will be implementing object-oriented Python programming with different functions and libraries. That will minimize this. Also, I will get standard on operating mode. So if we go file, restart, let's restart this code. Hopefully this time it will work further. Right, this time we started our camera. It is getting the feedback. Hopefully it will show the full feedback. Right, for now, then all ready to go. So I managed to fix the jumper wire issue. There was a jumper wire, it was dislodged here. So at the moment the robot is working. Just to summarize, the thing is that the robot sees the block. Basically it sees this block. This can be replaced with a round shaped ball or any other similar looking target, where it is easy to distinguish between the ratio of coming near and coming and going away from the in the viewer. So this one, if I just run the code now, yeah, so basically if I just run the code now, as you can see, this is going right, and the console, it is showing that the target is on right hand side, and the distance is there is some inconsistency of measuring the distance. It is getting various ratios because of the optimization hasn't been done yet. So if I move it in left side, so it is showing the left side, and at the same time the left wheels at the same time the left wheels are moving. I just have a look if it is visible. Yeah, it's visible. So at the same time the left wheels are moving, and as it is going the right hand side, the right wheels are moving. As I go more closer, the wheel will move reverse, just to get away from the robot itself. At the center position, the robot move forward, As I'm going more closer, it will go to the opposite direction. Yeah, as you can see, the opposite direction movement happen, though there is some inconsistency issue. And the same goes like if I go left side, the left side is moving. If I go right hand side, it is showing the indication that the camera has, the Raspberry Pi 4, the controller has already targeted. The main target is right hand side of the camera, and if we go left, it is targeting the left hand side of the camera. To compensate the whole thing, it is moving the vice versa. So if the target goes right, the left hand side motor will activated and right hand side motor is stopped. If the target moved right, then left side motor is activated. The left side motor is activated, and it compensates the movement in that way. Now, if it is on the central location, both the motor moves, and that means that the car should go forward. If it comes too close, keep an eye. If it comes too close, the motor will just go otherwise. To the central. So for now we come to the last stage of the video. I really wish that I could be more descriptive, but I seriously had some problem with using multiple cameras. But the description in my website, you will find it really helpful with all the codes and descriptions. Meanwhile, I'm always ready to help you guys. I'll be really happy that if you just put some comment with your question, with your feedback at the comment section below. And also same time, I also need your help, that you support me through subscribing and sharing and providing your feedback. Thank you for watching this video. I will see you at next time. Thank you.